Hey guys! So before we get started today with our notes, I just want to say congratulations because we have officially made it to our very last section of notes for distance learning and for the school year. So I'm so proud of you guys for all the work that you've done and for keeping up with everything, and just so thankful and grateful for everything that you've done these past 9 weeks. I know that it's been challenging and it's been an adjustment, but you guys have really done an awesome job and I am so proud of you. So thank you for all of the hard work that you've done. And without further ado, let's take our last section of notes. So I am on page 10 of the new packet, and what we're going to be doing today is just kind of a very brief little introduction of something that's going to be very important to you in math next year and pretty much any math class that you take going forward. So we're going to be talking today about degrees and radians. So before I talk about what degrees and radians are, I want you to think about a ruler. So on a ruler, if I asked you to just measure the length of something, you could use the inches side, right, and measure it in inches, or you could use the centimeter side and measure in centimeters. And if you needed to convert from one to the other, that would be possible. So there are there's a lot of units that we can use to measure length, but I would say the two units that we most commonly use for measuring length are inches and centimeters, the two sides of a ruler. So when we're talking about angles, right, trig is the study of angles. When we're talking about angles, there are two units that we use to measure angles, and they're called degrees and radians. So degrees are the ones that you're probably most familiar with because that's the way that you've talked about angles since you first learned what an angle is. So a radians are just another way of measuring angles, okay? So what we're going to talk about today is how to convert between the two and to kind of give you an idea and start to understand what angles look like when we measure them in radians. So the key to degrees and radians is understanding that one full rotation. So think about like if you spun around in a circle, right? Then you would be rotating 360 degrees. So one complete rotation, one whole circle has 360 degrees in it. If you rotate it all the way around, you would have a 360 degree angle. In radians, that's equivalent to 2 pi radians. So a lot of times in radians, pi will be a part of your measurement. And the reason for that is because that's an exact conversion. There are exactly 2 pi radians in 360 degrees. Those two measurements are exactly the same. Over here in my calculator, I'll show you that if I actually put in 2 pi is an irrational number. It's a decimal that goes on forever and doesn't repeat. So the reason that we use 2 pi instead of approximately 6.28 is that 2 pi is exact and 6.28 is an approximation. So a lot of times angles that are measured in radians will have a pi as a part of the measurement, and the purpose of that is to just keep the measurement exact. If you type the pi into your calculator, then you're going to end up with a decimal that goes on forever, and you would have to round it off, and whenever we round off, we lose a little bit of accuracy. So in order to prevent that, that's why you see the pi in most of your measurements. So when we're thinking about angles, there's some angles that are really important in trig. So when we're talking about angles in trig, angles always start, was it the best drawing there, straight line, but angles always start from the x-axis. They always start right here, that would be 0 degrees. So an angle that's just sitting on the x-axis is 0 degrees. And when we rotate, we always rotate up from the x-axis. So a few angles that are super important in trig. are 90 degrees. So a 90-degree angle would be right here. 180 degrees, 270 degrees, and then all the way around. So if we rotated all the way around the circle, this is what we just talked about, we would get back to the place where we started, which would be 360-degree angle. So those are 4 very important angles when we measure in degrees. They all have an equivalent when we measure in radians. So in radians, we would still be starting at 0. Okay, and remember that I said 1 full rotation all the way around is 2 pi radians. Okay, so keeping that in mind, half of 2 pi, half of the circle, then would just be pi radians. So 180 degrees is exactly the same as pi radians. It's just 2 different ways to measure that angle. 90 degrees is half of 180, so it would be half of pi. That's pi over 2 radians. 270 degrees is 3 pi over 2 radians. Okay? So those are your important angles labeled in degrees and radians. Remember that radians is just another way to measure an angle, just like inches and centimeters are 2 different ways to measure length. Okay, so one of the things that's going to be really important is being able to convert between the 2 different types of measurement. So when you have an angle that's in degrees, the way that you convert to radians is you multiply that angle by pi over 180. Pi radians and 180 degrees are exactly the same. That's what we just showed right here. So when we multiply by that, that's called the conversion factor. It's converting our angle from degrees to radians. The important part of this is that when you do this, you're going to leave the pi in your answer. So you shouldn't multiply the pi out in your calculator. You should leave the pi in your answer, and I'll show you what that looks like in just a second. So a 45-degree angle. So right now that's in degrees. If we wanted to convert that to radians, then we would multiply 45 by pi over 180 degrees. So that gives us 45 pi over 180. So we do want to simplify the fraction, but we're not going to multiply the pi out. So if you have a graphing calculator, this is really easy. You just type in 45 divided by 180, and it'll give you the decimal. And then to convert it to a fraction, you press math and that number 1, math fraction, and it'll convert your decimal to an answer. So 45 over 180 is the same thing as 1/4. So this angle in radians would be 1/4 pi radians. So you're leaving pi in your answer, you're only simplifying the number part of the answer. Okay, so doing the same thing in number 2. So it's in degrees. To get to radians, we multiply by pi over 180. So that would be 95 pi over 180. So in my calculator, I'm going to do 95 divided by 180. That gives me a decimal. And then math number 1 is going to turn that into the reduced fraction. So 19 over 36 times pi radians. Okay, so if you don't have a graphing calculator, then unfortunately you're just going to have to simplify the fraction kind of on your own. So I'll show you what you could do there in number 3. So when I multiply this by pi over 180, I get 150 pi over 180. So I can see here pretty clearly that those zeros cancel. I could divide both of those by 10, and then 15 over 8, both of those are divisible by 3. So this would be 5 pi over 6. So if you don't have a graphing calculator that'll automatically simplify, then you just have to simplify the fraction on your own. Okay, so to convert from degrees to radians, very simple. You just multiply by pi over 180. To go the opposite direction, to go from radians to degrees, we're going to flip that conversion factor. So we take our angle in radians, and this time we're going to multiply by 180 degrees over pi. And something kind of nice is going to happen with these. So this is my angle in radians, 2 pi over 9. So if I multiply it by 180 pi, sorry, that's not right, 180 divided by pi, then I would have 2 times 180 is 360 pi divided by 9 pi. So you can probably see here what happens is that your pi's are going to cancel out. That pretty much happens every single time when we convert from radians to degrees. The pi's should always cancel, and you should just be left with a whole number of degrees. So 360 divided by 9 is 40. So this would convert to 40 degrees. Okay, 3 pi over 5. So to convert it to degrees, we would multiply by 180 over pi. 3 times 180 is 540. So this is 540 pi over 5 pi. Again, the pi's cancel, and so we just do 540 divided by 5, which is 108. So this would convert to 108 degrees. Okay, and last one, multiply by 180 over pi. 7 times 180 is 1,260 pi in my numerator, 4 pi in my denominator. The pi's cancel, and when we divide 1260 by 4, we get 315 degrees. So for the ones that we're going to do, when you're converting from radians to degrees, your pi's are always going to cancel, and you should end up with an even number of degrees. If you have a decimal, it shouldn't be a decimal that repeats. You might get something like 0.5, but for the most part, those should convert pretty nicely for you. Okay, so these are just two relationships that you need to learn, how to convert from degrees to radians and radians to degrees. And it's just multiplying by that conversion factor. So essentially, whatever unit you're ending up in, that's the one that's in your numerator. So if I want to end up in radians, when I wanted to end in radians, go to radians, the pi was in my numerator because I want to end up in radians. When I want to end up in degrees, the degrees are in my numerator because that's where I want to end up. All right, so the last part of this section is to just kind of get you familiar with how to sketch angles and what some different angle measurements look like. So all of these measurements or all of these angles are pretty much based off of understanding what each axis represents. So 100-degree angle. So if you think about what the 4 different axes represent, 0, this one was 90, this one was 180, 270, and then all the way back around is 360. So 100 degrees is a little bit more than 90 degrees. So a 100-degree angle would always start on the x-axis. That's never going to change. And it would be rotating a little bit past 90. So 100 degrees would be somewhere like right here. Obviously, it's much less than 180. So it should be closer to 90 than it is to 180. So 280 degrees. So we know that the negative y-axis is 270. A whole revolution would be 360. So if we start at 0, rotating 280 degrees would be just a little bit past 270, okay? And finally, 70 degrees. So 90 degrees is the y-axis. So 70 degrees is obviously going to be less than that. So if I started at 0, I would rotate and end before I got to 90 degrees. So that's how you sketch angles. Just think about what the axis represents and where your angle falls with respect to what we know, the 90, the 180, the 270, and the 360. All right, so last part of this. When angles are given to you in radians, to sketch them, just convert them to degrees first. So just apply your conversion factor. Remember that if we're going 2 degrees, that our degrees would be in our numerator. So we just multiply this by 180 over pi. That gives us 180 pi over 3 pi. Pi's cancel. So this is 60 degrees. 60 degrees is obviously less than 90. So if I start at 0, I would rotate to 60 degrees right about there. 5 pi over 4. So if we convert this to degrees, we would multiply by 180 over pi. 5 times 180 is, 5 times 180 is 900. So I would have 900 pi divided by 4 pi, which is 225 degrees. So thinking about what each axis represents, 225 is going to be between 180 and 270. It's actually halfway between them. So starting at 0 degrees, 225 would be a rotation to right there. And last one, 11 pi over 6. So converting this one to degrees first, you have 11 times 180, which is 1,980 pi, divided by 6 pi. So our pi's cancel. Divide by 6, and that ends up being 330 degrees. So 270 and 360, 330 is going to be somewhere between those. So starting at 0, rotating, 330 would be somewhere like right here. Okay, so whenever you're sketching an angle, whenever you rotate, you always rotate up from 0 degrees. So if I was rotating to 90, I would stop at the y-axis. To rotate to 180, I keep going, rotate to 270, and then 360 would be all the way back around. All right, so hopefully this doesn't seem too bad. Again, radians are something that are going to become really important to you in AFM and pre-cal and calculus. Our goal here is to kind of introduce them for you to see that they're just another way of measuring angles and to understand how to convert back and forth between degrees and radians. And remember that when you're converting to radians or when you see radian measurements, a lot of times they're not, or they're going to have the pi in them, and the purpose of that is to just keep it an exact measurement. So when you're doing your conversions to radians, make sure that you're leaving the pi there. Don't type the pi in your calculator. You want to leave that as a part of your answer. Okay, so you have a little bit of practice now to do with degrees and radians and a short assessment this week, and that is it. We're almost at the end of this unit. So congratulations on making it to your very last video. I'll see you guys soon. Bye.